Hello and welcome everyone to yet another tech enthusiastic video from Edureka. I am Ravi and today I'll be handling your C++ tutorial. C++ is a general purpose programming language created by Brane Strausstrup as an extension to C programming language. It is considered as the most important and basic requirement to understand the object-oriented style of programming. In this C++ tutorial, we shall understand the following important concepts as described in the agenda below. So firstly, we shall deal with the basics of C++, where I'll explain to you a little bit history of C++. Followed by that, we shall deal with the features of C++, installation of C++, first C++ program. Then we shall understand the detailed structure of C++ program. Then we'll come to know identifiers, keywords, whitespace, data types used in C++, variables, modifiers and type qualifiers. Then we shall understand the operators used in C++. After that, we shall get to know the conditional statements and loops in C++. Next, we'll move into object-oriented programming, where I'll explain to you the concepts of encapsulation, abstraction, inheritance, overloading, overriding, interface, friend function, constructor and destructor, and finally, the standard template library. Once we are finished with the object-oriented style of programming in C++, we shall move ahead into the advanced C++ concepts, where I'll explain to you the file handling techniques, streams, exception handling, dynamic memory management, signal handling, multi-threading, and containers. And finally, we shall wrap up the session with some important interview questions based on C++ programming. Now, without wasting much time, let us quickly begin with our first topic, C++ basics. Firstly, the history of C++. The C++ programming language is developed in the year 1980 by Mr. Brane Strausstrup at the well-established Bell Laboratories of American Telephone and Telegraph, popularly known as the AT&T Company, positioned in the United States of America. He developed C++ programming language in order to integrate the object-oriented style of programming into C language without having to make any significant change to the C fundamentals. Now, with this, we shall move into the important features of the C++ programming language. So firstly, we have rich library. C++ language incorporates multiple built-in arithmetic and logical functions along with many built-in libraries which make development faster and convenient. Next, we have the object-oriented style of programming. C++ programming language is designed to be an object-oriented programming language. Object-oriented programming style makes development and maintenance easier, whereas in case of procedure-oriented programming languages, if the code grows, the complexity grows proportionately. Now, let's move on to the next feature, which is compiler-based. C++ programming language is a compiler-based programming language. It means without compilation, no C++ program can be executed. First, we need to compile our program using the compiler, and then we can execute our program. Followed by this, the next feature is extensible. C++ programming language is highly extensible because of its easy adaptable features. Next feature is recursion. C++ language supports function backtracking, which involves recursion. In the process of recursion, a function is called within another function for multiple number of times. Then we have pointers. C++ enables users to directly interact with memory using the pointers. We use pointers in memory, structure, functions, array, stack, and many more. Then we have structured. C++ programming language supports structured programming, which includes the use of functions. Functions reduce the code complexity and they are totally reusable. And finally, we have memory management. C++ provides the best-in-class memory management. It can both allocate and deallocate memory dynamically at any instance of time. Now, let us move on to the next part of our session where we'll learn to install C++ in Windows. Now, allow me to guide you the step-by-step procedure to install C++. Firstly, we would need an editor. So, to run C++, we have multiple text editors. For example, Dev C++, Turbo C, CodeBlocks, Visual Studio, Eclipse, and many more. So, in this tutorial, I'll be using Dev C++. To install Dev C++, all you need to do is to download Dev C++ into your local system. For that, you need to Google Dev C++ first. Click the first link and you will be directed to the next home page of Dev C++. And in here, all you need to do is to just select a download button here. So this is the download button. Please click on it and the file will be downloaded into your local system. So once after the dev C++ installation folder is been downloaded into your local system, it looks something like this. Now all you need to do is install that. Just click on it and you'll be shown up with a dialog box. Select yes. Then you will find a dialog box saying unpacking data. Select OK. Then select I agree. Next. And select the install button. Once the installation is finished, select the finish button and you'll be finding the dev C++ text editor opening. You can choose English original language here. Then you can choose the color and font for your coding and press next. Select OK and you have your text editor. To start with your text editor, select File and New, and inside New you can either select a project or a source file. Let me select a simple source file here, and that's how you get it. Now let us execute our first C++ program. So this is our first C++ program here. We are trying to print hello world message using this program. To run the program, you need to select the execute option from the menu bar. Once you select that, you'll be having three different options here. First one is compile, then you have run, and finally you have compile and run. So it's better you use compile and run while your program will be compiled. Along with that, after the compilation, your program will run automatically. As you can see, my program is getting compiled. And the output is been generated onto the terminal. So this is the message what we wanted to print, hello world. Now, followed by this, let us understand the structure of a C++ program. So the basic structure of a C++ program involves C++ headers, class definition, member functions, and main function. Now let us understand each one of them in detail. Firstly, the C++ headers. The lines starting with hash symbol are considered to be the header files. So in our program, hash include IOStream is considered to be the header file. So all the header files are used in a program have their own unique meaning. For example, the header file which we have included, which is none other than the IOStream, instructs the preprocessor to perform standard input and output operations, such as writing the output of our first program on the screen. Now followed by that, we have the namespace. A namespace allows grouping of various members like classes, objects, functions, and various C++ tokens under one single name. Various users can create separate namespaces and thus can use similar names for other members. This avoids the compile time error that may exist due to the identical name conflicts. Followed by this, we have the class definition. This is a simple hello world program, so I did not include a class, but in the future programs, we will be dealing with classes. For now, let us understand class definition. The class is a user-defined data structure declared with the keyword class. It includes data and functions as its members, whose access will be governed by three access specifiers, namely private, protected, and public. By default, access members of all C++ classes are private. And finally, we have the member function definition. The member functions are the operators and functions that are declared as members of a particular class. The member functions are also called as friend of the main class. Finally, we deal with the main class or the main function. The main function is also known as the entry point of every C++ program. When a C++ program is executed, the execution control goes directly into the main function. So this is the basic structure of a C++ program. Followed by this, let us move on to the next topic, which deals with the identifiers used in C++ programs. So what are identifiers? Identifiers in C++ language are none other than the names assigned to the variables and functions used in a C++ program. The valid identifiers in a C++ program are declared using alphabets from capital A to capital Z, or small a to small z, and even you can declare a name using the numbers starting from 0 to 9. The identifiers cannot include special symbols and white spaces, but you can include an underscore. One basic example of valid identifier is int x is equals to 10. Now let us discuss some rules to declare identifiers in C++ program. So the rules are simple. First character should always be an alphabet or an underscore. Followed by that, Succeeding characters can either be digits or letters. The third rule is that special characters are not allowed except the underscore. And fourth and the final rule is identifiers should not be keywords. To understand these rules, let us check out some valid identifier names as well as some invalid identifier names. Firstly, we have int a, which is a valid identifier because it is starting from an alphabet. Followed by that, we have another one which is int underscore ab, which is also valid because it is starting from underscore. Then we have int a30, which is valid because the first letter is starting with an alphabet. Followed by that, we have numbers. Then let's check out the invalid identifier names. We have int 2, which is starting with a number, so it is considered to be an invalid identifier. Then we have int a white space b. It is starting with an alphabet, but it includes a white space, which is not allowed. Then we have int long. So the fourth rule speaks about this type of identifiers. Identifiers should not be keywords. We have long, which is a keyword that is a data type. So you cannot name your identifier with a data type or a keyword. So these are the few rules for declaring identifiers. And with this, let us move to the next chapter, that is the keywords. So what are keywords? Similar to identifiers, we do have some special and reserved words in C++ program which have their own special meaning. Such words are called as keywords. Some of the keywords used in C programming language are as follows, and after that we shall deal with some new keywords which are introduced from C++ language. So these are the keywords which are used in C programming language as well as C++ programming language. So they include default, break, case, char, long, and many more like delete, struct, switch. Now let us move to the keywords which were introduced from the C++ programming language. So these are the new keywords which are introduced from C++ programming language. They are ASM, delete, virtual, template, inline, protected, throw, catch, and many more. So with these, let us move on to the next chapter. The next chapter is whitespace. Whitespace can be defined as a term used in C++ programming language to define blank spaces, tab spaces, new line characters, and comments. Whitespace separates one statement from another and enables the compiler to identify where one element in a statement, such as an int, ends and the beginning of the next line. Let us consider a basic syntax to understand whitespace. Here we have char Edureka happy learning. Char is a data type and Edureka happy learning is the name of the variable. So between the both we have a space which is the whitespace. Now we have understood what exactly whitespace is, so with this let's move on to the next chapter called commits. So in C++ program, commits are user-written statements that are included in every C++ code for explanation purpose. These commits help anyone reading the source code. All programming languages allow some kind of commits. C++ supports both single-line commits and multi-line commits. Let us see how does these commits work. So this is our basics first hello world program. Now let us try to add single-line commits here. To add single-line commits, you need to type in 2 forward slashes. After that, you need to type in your message. So here, let me type in single-line commit. So this is how the single-line commits work. Now let us try to deal with the multiple line commits. To write in the multiple line commits, you need to replace the forward slash with an asterisk. So here, the lines from hello world written and the closing bracket, everything is commented. In order to close the multiple line commit, you need to end the commit with asterisk and forward slash. This is how the multiple line commits end. So these are the ways to declare multiple line commits and single line commits in your C++ program. Now with this, let us move on to our next chapter, that is about data types used in C++ programming language. So the 3 basic data types used in C++ programming language are derived data types, built-in data types, and finally the user-defined data types. First, let us deal with derived data types. So some of the examples for derived data types are arrays, pointers, function, reference, and many more. Let us deal with each one of them in detail. Firstly, let's deal with arrays. So what is an array? An array is defined as a collection of similar type of data items stored in continuous memory locations. The array is the simplest data structure where each data element can be randomly accessed using the index number or the address number. So in C++ programming language, we have three different kinds of arrays. They are one-dimensional array, two-dimensional array, and multi-dimensional array or JART array. So let's see each one of them. Firstly, let us understand one-dimensional array. So one-dimensional array can be defined as an array with single row and multiple number of columns. So the elements in one-dimensional array are accessed using their index numbers. Now let us understand the terminology of one-dimensional array. For example, consider that you have declared an array of size 5. So what the compiler does is, it will select one bigger block of memory, then divide the block of memory into 5 different parts, and those 5 blocks will be allocated to the one variable which is none other than your array variable. So here I have selected my array variable to be my array, and now compiler has given me 5 continuous blocks of memory to store integer type of data because my array is integer type and I have reserved 5 blocks. Now let us try to store some data into my one-dimensional array called my array. So firstly, I'll select 10. So the element 10 will be stored in the first memory location of the array, which is 0. Always remember, the array starts from the memory location 0. Followed by that, we shall add in few more elements, which are 20, 30, 40 and 50. So the data is been allocated into the array in a continuous format. So this is how the one-dimensional array works. Now let us execute a simple example to understand one-dimensional arrays in a much better way. So this particular example is based on one-dimensional array. I have declared my array variable as ARR and I'm trying to store 5 elements into my ARR array. Let us execute this program and see how does it work. You can either choose execute and compile and run option, or you can just press F11 as a shortkey to compile and run your program. You can see my program has been successfully executed and I have the output here. As you can see, I have successfully included all the elements into my array and I tried to print out one particular element from my array which is at the array index number 3. So in the array index number 3, we had 4 and that was the one which was displayed on our terminal. Now with this, let us move on to the next type of arrays, which are the two-dimensional arrays. The two-dimensional array can be defined as an array of arrays. The 2D array is organized as matrices, which can be represented as the collection of rows and columns. The elements of an array are accessed using their intersection coordinates. Now, let us understand how do they work. Here, let us consider our array as ARRAY. So ARRAY or array is my array variable's name here, and I have declared an array with 2 rows and 5 columns. Now, let us try to insert an element into the array. So I'll select first element as 10. You can see the intersection coordinates as 0, 0. So 0, 0 happens to be the first memory location of my array here. So the 10 element will be stored in the first memory location. Followed by that, let us include few more elements into my array now. So we have 20, 30, 40, 50, 60, 70, 80, 90 and 100. So all these elements will be allocated into my array in continuous memory locations based on their coordinate numbers. So let us see how does it happen. You can see they are arranged in a sequential manner. So 20 is at 0, 1, 30 is at 0, 2 and finally 100 is at 1, 4. Now to access these elements, we have to provide their index numbers or the intersection coordinates here. Now let us execute a simple two-dimensional array example to understand them in a much better way. So this is the basic example for two-dimensional array. So here my array name is test and I have provided 3 rows and 3 columns. So the elements that I am going to enter into my three-dimensional array are 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now we have 2 for loops here. So first for loop will be for the rows and the second for loop will be working for the columns. Now let us try to execute this program and see how does it work. You can see that the elements have been successfully included into my array along with their intersection coordinates here. So 0, 0 which happens to be the first memory location saves my first element 1 and 2, 2 happening to be the last memory location saves my last element 9. So now with this, let us move on to the next type of arrays, which are the multi-dimensional arrays or also called as JART arrays in C++. So the multidimensional arrays can be defined as an array of arrays. The 3D array is organized in the form of a 3D matrix, which can be represented as the collection of multiple rows and multiple columns. The elements of the array are accessed using the 3D intersection coordinates. So here we have a vertical column, horizontal row, and another row which is in perpendicular with the horizontal row and the vertical column. Now let us execute a simple program to understand its terminology. In this particular program, we are going to enter 12 different values manually, and the name of my array is test, which has 2 rows, 3 columns, and 2 rows which are perpendicular with the rows and columns. Now we have 3 different for loops here. First one will be for the rows, second one will be for the columns, and third one will be for the row which is in perpendicular with the row and column. Now let us execute this program and see how does it work. Don't worry about the codes, you can mail us for them at any time and we will reply you as soon as possible with the codes you need. Now let us enter 12 different values. Let me enter 1 to 12. As you can see, all my 12 elements have been included into the array from 1 to 12. 1 being located at the first memory location, which is 0, 0, 0, and 12 is located at the last memory location, which is 1, 2, 2. So this is how the multi-dimensional arrays work. Now with this, let us continue with our next part of the session, which is related to the linked lists. So what are lists? Lists are the linear data structures completely similar to that of arrays, but the only difference is that the elements are not saved in a sequential memory locations as we used to do in arrays. Instead, they are sorted in random addresses and connected using pointers. So we have 3 different kind of linked lists in C++ similar to C, which are singly linked lists, doubly linked lists, and circular linked lists. Firstly, let us understand the working terminology of lists. Here, we will be having a random memory heap in our computer system. So what exactly happens is, if you want to store 5 different elements into your list, then the computer will select 5 random blocks from the memory heap. So here you can see that we have 5 random blocks from the memory heap with different addresses. First one is 1001 and the other one is 1023, then 3026 and 4537 and finally 7328. Remember the last block here? There is something happening here when we store the elements into the linked list. Now let us store the elements. You can see that 10 is allocated to the first one, 20 to the next one, 30 to the next one, 40 and finally 50 to the last one. The change happened here is the last memory location is allocated to null. This means that this is the end of the list. So here, how are they connected now? These are the addresses. So every block has a different address. So what compiler does is, it will connect this block with this block, where this block will be pointing to the address of this block. So actually, this particular address is not the address of this memory block. This particular address is the connecting address of the next memory block. So similarly, you have the address of the next connecting memory block here. This is how the linked lists work and they get interconnected with each other. Once the linked list is complete, then we have the head node and the tail node. Once the linked list is complete, all the blocks are considered as nodes. Firstly, we have the head node, which is the starting part of the linked list, and at last we have the tail node, which is called as the ending part of the linked list. Now let us deal with the types of linked list. We have 3 different types of linked list in C++. Firstly, we have singly linked list, then we have doubly linked list, followed by that we have circular linked list. Now let us understand the terminology of singly linked list. So this is singly linked list. Singly linked list contains 2 different fields, namely the address of the next node and the data assigned to the present node. So this particular node is known as the head node and this is the address block which is pointing to the next upcoming node. So here we have the head node where the memory is being stored and this is address block where the address of the upcoming node is stored. Now let us execute a simple example to understand the terminology of singly linked lists. So this particular example is based on singly linked list. Now let us try to execute this. Once we execute, we'll be provided with 4 different options First one will be for inserting elements into the linked list. Second one will be to delete the elements from the linked list. And third one will be to display the elements in the linked list. And finally, we have the count for counting the number of elements in the linked list. Other than that, we can give a random input to exit the linked list. Firstly, let us insert. Now we have inserted 4 different elements into our linked list. Let us display the elements. We can select number 3 to display the elements. So you can see that we have 4 different elements, which are 1, 2, 3, and 4. Now let us try to delete the element number 4. Let us select option 2. Now the compiler is asking for us to give the position of the element. Remember, we had the elements starting from 0 in arrays, but in linked list, the elements start from 1. So to delete the element 4, we need to give the address 4. You can see the 4th element has been successfully deleted. Let us check out the elements remaining in the linked list. You can see that we are remained with 1, 2, and 3. Now let us try to count the number of elements in our linked list by providing option number 4. You can see that the output is 3. Now let us try to exit our linked list. We are done. Let us try to understand the next type of linked list, which are the doubly linked lists. So doubly linked list is completely similar to singly linked list, but the only difference is it is traversable in both directions. When you come back into the singly linked list, you can see that you can traverse from head to tail, but not from tail to head. The singly linked list can travel in only one direction, but not in 2 directions. But when you come into the doubly linked list, you can travel in both the directions, starting from head to tail, and you can also come from tail to head. So this is the speciality of doubly linked list. The doubly linked list has 3 particular blocks. One to store the address of the previous block, and the one to store the memory, and the last one to store the address of the upcoming node. So this is how the doubly linked lists work. To understand this in a much better way, let us execute a simple example. So this particular example is based on doubly linked list. Now let us execute this. As you can see, the program has been successfully compiled, and now the system is asking for 4 different options. 1. To insert elements into the linked list. 2nd, to delete the elements. 3rd, to reverse the linked list. And finally, the 4th one, to exit. Now let us try to add in some new elements. As you can see, we have inserted 5 different elements into my linked list, which are 10, 20, 30, 40, and 50. Now let us try to delete one element from our linked list by providing option number 2. Enter the element to be deleted. Now let us delete 30 from our linked list. You can see the element 30 has been eliminated from our linked list, and we remain with 10, 20, 40, and 50. Now let us try to reverse the linked list. So let us select option number 3. After reversing, you can find that the elements have been completely reversed from 50, 40, 20, and 10. Now let us try to exit the program. So this is how the doubly linked lists work. So with this, let us move on to the next type of linked list, which are the circular linked lists. There is no much difference between the circular linked list and the singly linked list. But the major and one and only difference is that in singly linked list, the tail node had the address of null. But here, the tail node is pointing back to the head. So this is how the list gets connected with each other, and it behaves like a circular linked list. Now let us execute a simple example to understand its terminology. So this particular example is based on circular linked list. Now let us execute this program and see how does it work. You can see that the program has been successfully executed, and we have the output here, and it says the circular linked list created is as follows, which is 30, 20, 10, 40, 50, and finally the tail is getting back connected to number 30. So this is how the circular linked list works. And after that, we have also tried to eliminate the number 10 from our linked list. So after eliminating, we have 40, 50, 30, 20, and again it is connected back to 40. So this is how the circular linked list works. With this, let us move on to the next concept, that is about stack. So what exactly is stack? Stack is a linear data structure which allows a particular order in which the operations are performed. The order may be LIFO, that is last in first out, or FILO, which is first in last out. Let us understand this practically. So what exactly stack is? Stack is completely similar to that of array, but the only difference is to access the elements we need to follow the terminology called first in last out or last in first out. So what is this? Let us understand this through this simple example. So here I have this sample stack named as my stack. This stack stores integer type of elements. So let me include my first element, which is 10. So what happens here is, in the same way that we saw in arrays, the element 10 will be stored in the first memory location of the stack, that is 0. Followed by that, let us try to include few more elements in the same way. We have 20, 30, 40 and 50. So these elements will be stored in sequential order in the same way which happened in arrays. Now, if you want to access the elements from the stack, then you need to follow first in last out procedure or last in first out procedure. For example, if you want to access the element number 10, then you need to exit 50, 40, 30 and 20 first from the array. Then you'll get the access to number 10. Let us see how does it work. Let us remove 50 first, then 40, then 30, then 20. And finally, you will be able to access element 10 from the stack. So to access the element 10 from the stack, you need to eliminate all these elements first. So this is how the stacks work. Now to understand this in a much better way, let us execute a sample code. So this particular example is based on stacks. Let us try to execute this. As you can see, the program has been successfully executed and the elements are same which we chose for our stack, which are 10 to 50. So my stack is having 50, 40, 30, 20 and 10 elements, and size of my stack is 5. And the top element is 50 as we chose in our stack. The first element which is on the top of the stack is 50. So we need to pop all these elements to access the number 10. So this is how the stacks work. Now let us move on to the next concept in our tutorial, which is none other than queues. So what is queue? A queue is a linear data structure which follows the particular order in which the operations are performed. The order is first in, first out. Remember, we had the order first in, last out in stack, and in queue we have first in, first out. Let us understand the terminology how queues work. Queue is also completely similar to that of stack, but the only difference is, in order to access the elements in stack, you need to follow a different order from stacks. In stacks, we used to follow first in, last out, but here you can use first in, first out. So let us see how does it happen. So let me store the element 10 in my queue. So the element 10 will be stored in the first location, which is 0, similar to that of stack. Let us include few more elements, 20, 30, 40 and 50. So my queue is full now, starting from 10, 20, 30, 40 and 50. So in queue, what we used to do is, to access the element 10, we were supposed to pop 50, 40, 30 and 20. But in case of queue, we can directly access 10, which is first in, first out. So to access 10, we can directly pop out the element 10 from the queue. Now next we can pop 20, then we can pop 30, followed by that we can pop 40 and 50. So this is how queues work. Now to understand this in a much better way, let us execute a small example. So this particular code is based on queues. Now let us try to execute this. You can see that the code has been executed and now it is asking for 3 different options. 1 to insert, 2 to remove, 3 to display and others to exit. Now let us try to insert elements into our queue. First, let me insert 10. Then 20. Now let us try to eliminate number 10 from my queue. To eliminate, I need to select the option number 2. So the first element which was removed from the queue is 10. Now if I choose 2 again, then the next upcoming element is 20, which will be removed from my queue. You can see 20 has been successfully removed now. So similarly, it removes 30. So this is how the queue works. Now let us try to display the elements present in my queue. So to display the elements, I need to select the option number 3. So you can see that I am remained with 2 elements which are 40 and 50 in my queue. Now let us try to exit our queue by providing option number 4, which is other than 1, 2, 3. This is how you exit. So now with this, let us move to the next part of our tutorial, which is functions. So what are functions? Function is a subdivided program of the main program that performs a specific predefined task. It can be reused, so this reduces code complexity. So the syntax for functions is return type, function name, and parameter list. So to understand functions in a better way, let us execute a sample code. So this particular example is based on functions. So what I'm basically trying to do here is I've declared a function here by name sum, which will be performing addition operation. And in my main program, I'm trying to call the same function by the name sum, and I'm passing 2 different parameters here, which are 25 and 20, and I'm trying to add them up. Now let us try to execute this program and see how it works. You can see that the program has been successfully executed and we have the output here. So this is how the functions work. Now let us move on to the next part of our tutorial, which happens to be reference. So what is a reference? A reference variable is an alternate name for the original variable. You can see that I have provided a basic example here. I have declared a variable on the name hello, which is of integer type, and it stores number 1. And now here I'm trying to declare another variable by name world, which has an ampersand symbol here, which says that it is a reference variable. Now this particular reference variable is pointing to the variable hello, so it can access the data which is present inside my hello variable, which is 1. So this is how reference variables work. Now after this, we have the applications of reference variables. There are 2 ways in which we can access reference variables, which are call by value and call by reference. Now let's execute a sample program to understand this application. So this particular example is based on reference. This is the first way of applying reference in a C++ program. This is by call by value. So let's execute this program and see the output. You can see the program has been successfully executed now. After this, let's try to execute the same program in call by reference manner. Now we are going to try to execute the same program in call by reference manner. Now let's try to execute this. You can see that the program has been successfully compiled and we got the output. Now after the reference, we shall move on to the next concept, that is about pointers. So pointer in C++ is a variable which stores the address of another variable. This variable can be the type of int, char, array, function, or any other pointer. The size of the pointer totally depends upon the architecture. So the pointer in C++ language can be declared using the asterisk symbol. So here you can find an example, int n is equals to 10. Followed by that, we have the pointer variable of integer type, which is declared using the asterisk symbol, and it stores the address of my first variable n. So this is how the pointers work. Let us execute one simple program to understand pointers. So this particular program is based on pointers. Now let us execute it. You can see that the program has been successfully executed and the address of pointer is shown here and the value stored in the variable is also shown. Now let's move on to the next concept. So the next concept is based on strings. So what are strings? The string is defined as one-dimensional array of characters terminated by a null character. The character array or the string is used to store text such as words or sentences. Each character in the array occupies 1 byte of memory and the last character must always be 0. So we have 2 types of strings, which are char array and string literal. Now let us execute an example to understand strings. So this here is an example for strings. Here I'm trying to print 2 different messages, which are hello world, welcome to Edureka, happy learning. Now let us try to execute this program. So here we go. We have hello world and welcome to Edureka, happy learning printed here. Followed by this, we have some important string functions in C++, which are string length, which describes the length of the string, Followed by that, we have string copy, which copies one string from a source to another destination. Then we have a string concatenation, which is used to join two different or more strings. Then we have a string compare, which compares given two strings. Then we have string reverse, which reverses the given string. String lower and string upper. The string lower converts the text from uppercase to lowercase, whereas the string upper is vice versa. Now, let us try to execute all these string functions in one single program. So this particular example is dedicated to execute string functions. So we'll consider string copy, string concatenation, and string length. So our strings are Edureka, happy learning, and the last string 3 is completely empty. Now we'll try to execute this and see how does it work. So firstly, what we did is copying the string 1 into string 3. That is, string 1 had Edureka, and now this memory is been copied to string 3. Later, we have string concatenation, where we try to concatenate two strings that are Edureka and happy learning. And finally, the Edureka happy learning result is stored into the first string, that is str1. Now we will find out the length of str1, which happens to be 22. So this is how string functions work. Now followed by that, we shall move on to the next topic, which is the built-in data types. So the built-in data types available in C++ programming language are as follows. They are char, signed char, unsigned char, short int, signed short int, unsigned int, signed int, unsigned int, long int, signed long int, unsigned long int, float, double, long double, and W character T. So they are mentioned along with their bandwidth and typical range. Followed by this, we have the user-defined data structures. The first one amongst the user-defined data structures is the structure. So what is a structure? So structure is defined as a user-defined data type available for C++ that allows to combining data items of different data types together. Structures are used to represent a record. Struct is the keyword which is used to declare structures. So this here is a basic example of structures where I have used struct keyword and my structure name is school. So my structure is saving integer data type, which is ID of a student. And followed by that, we have a string data type, which happens to be the name of the student. And lastly, I have float data type, which happens to be the percentage of that particular student. Now, let us consider executing an example to understand structures in a better way. So this particular program is based on structures where point happens to be my structure. Now let's execute this and see how does it work. You can see that the program has been successfully executed and the output has been printed here. Now let us move to the next part of the user-defined data types, which is enumeration. So what is enumeration? Enumeration in C++ is a user-defined data type. It is designed to assign names to an integral constant. The names increase the readability of the program and also the program becomes very easy to maintain. Enumeration is completely similar to that of structure, but the only difference is whatever the data you save in an enumeration using the keyword enum, then the value stored in that particular enum will be constant. You cannot remove the elements from enum, but you can add in some new elements to the enum. Now let's execute a simple program to understand what exactly enums are. So this particular program is based on enums, where my enum name is week. The days of a week start from Monday to Sunday and all these values stored are constant. You cannot remove any values from this particular enum, but if you want to try to add in some more, you can add. But in this particular context, you cannot add more days to a week, but in some other context, you can add in some more. Now let's try to execute this program. So this is how the enum works. Now what I've tried to do is to display the location of the day Wednesday. So this starts from 0, 1 and 2. So the location was 2. That's what displayed in the terminal. Now let's move on to the next part where we deal with a class. So a class in C++ is actually a user-defined data type. It's declared with a keyword class at the side of its members with personal, protected or public access specifiers. By default, all the members of a C++ class are private. Now let's execute a simple program to understand classes. So this particular example is based on classes. So here, student happens to be my class. And inside that, I have provided two different data types. One is integer type, which stores the ID of the student, and the other is string type, which stores the name of my student. And inside my main program, I have a constructor named student. Then using this constructor, I'll be trying to input the data into my class. So now let's try to execute this and see the output. You can see that the program has been executed successfully, and the roll number and the name of the student are being successfully printed here. So this is how the classes work in C++. Followed by that, we have a union. So what is a union? Union is completely similar to a structure in terms of declaration and usage, but all the members of a union occupy the same space in memory. That is, the same memory location is shared among all the union members. Now let's try to execute a sample program to understand how unions work. So this particular program is based on unions. Now let's try to execute this and see how does it function. You can see the code has been getting compiled and the output has been successfully generated, and we have the output here where A is 5, A is 10890511034, and B is 7.3. So basically what I have done here is I've declared a union, and inside the union I've declared variable A and variable B, which are of different types, integer and float respectively. And inside my main function, I have tried to do some operations upon these variables, and the results of those operations are being displayed here. So with this, let's move on to the next segment where we'll learn about variables used in C++. So variable is defined as the reserved memory space which stores the value of a definite data type. The value of a variable is not constant. Instead, it allows changes. So in C++, we have different types of variables which are as follows: local variable, global variable, static variable, automatic variable, and external variable. So firstly, let's understand local variable. So any variable that is declared inside the code block or a function and has scope defined to that particular block of code or function is called as a local variable. So for example, here I have void Edureka, which happens to be my function, and inside this function I have declared a variable on the name local variable. So this particular variable is storing the value 10, and now the scope for this particular variable is confined to the function Edureka. This means the local variable is not capable enough to be accessed outside the function Edureka. So this is how the local variables function. Followed by this, we have the global variable. So what is a global variable? Any variable that is declared outside the code block or a function and has scope across the entire program and allows any function to change its value is known as global variable. So basically, the global variables are declared outside all the functions and before even the main function is started. By doing this, the programmer will be capable enough to access the global variable from any function or any method, and even from main. And all the functions, including the main method, can change the values which are present in the global variable. Here, I have declared a global variable of integer data type, and it is saving the value 10 inside it. And you can see that the global variable is declared outside the Edureka function. So now I can access this global variable from my function or my main function and change its value after applying any particular operation on global variable. So this is how the global variables work. Followed by this, we have static variables. Any variable that is declared using the keyword static is known as a static variable. Static variables retain the declared value throughout the entire execution of the program and will not be changed between multiple function calls. Here you can see that I have used the static keyword. Followed by that, I have provided a data type which is integer, and I have declared my static variable which stores the value 10. Now this particular value 10 will not be changed even after you apply any kind of operations onto this particular static variable. So this is the functionality of static variable. Followed by this, we have the automatic variable. So the automatic variables can be declared using the keyword auto. By default, all the variables declared in C++ language are automatic. Followed by that, we have the external variable. External variables are declared by using the keyword extern. We can share a variable in multiple C++ source files by using the external variable. For example, I have declared a variable by the name external, which is of integer data type, and I've stored 10 inside that variable. And we need to concentrate that I have declared this particular variable using the keyword extern, which makes this particularly an external variable. An external variable is also called as a global variable. Now after this, let's check out some rules for declaring variables. The rules for declaring variables are completely similar to that of identifiers, which say a variable can have alphabets, digits, and underscore. A variable can start with an alphabet and underscore only. It can't start with a digit. Followed by that, no white spaces are allowed within the variable name. And the last rule is that a variable name must not be any reserved word or a keyword. Example, integer, float, etc. Now let's see some examples for valid variables names. First one is integer a, which starts from an alphabet, so it's valid. Followed by that, we have another one which is of integer data type and it's starting with underscore. So this is valid. Followed by that, we have integer a30, which is also valid because it's starting from an alphabet and it is continuing with a number, which is valid. So now let's check out some examples for invalid variables. Firstly, you have integer 2. So this particular variable is starting with a number which happens to be 2. So it's invalid. Followed by that, we have another example where we have declared int a space b. So this particular variable name includes space. So spaces are not allowed to be declared for variables. Followed by that, we have int long. So we cannot use long because long happens to be a data type and a keyword in C++, so it's invalid. Now let's begin with our next topic, modifiers. So what are modifiers? So the modifiers in C++ allow the character, int, and double data types to have modifiers preceding them. A modifier is used to alter the meaning of the base type so that it more precisely fits the needs of various situations. The data type modifiers available in C++ are signed, unsigned, long, short. Now let us execute a simple example to understand how exactly modifiers function. So this particular example is based on type modifiers where I have declared two variables of short int I and short unsigned int I. So j is storing the value of 50,000 and I is declared is equals to j. So when it's modified into unsigned int, the value will be changed. Now let's check out this. You can see that the program is getting compiled and the output has been displayed here. The modified value is minus 15,576 and the actual value which we have given to the unsigned int was 50,000. So the original value was 15,536 with this symbol minus. Let's move on to the next topic, which is based on type qualifiers. So the type qualifiers provide additional information about the variables they precede. There are three different type qualifiers present in C++ language. They are const, volatile, and restrict. Let's understand each one of them in detail. Objects of const type cannot change the program during execution. Next we have volatile. The modifier volatile tells the compiler that a variable's value may be changed in different ways, not explicitly specified by the program. Then finally we have a restrict. A pointer qualified by restrict is initially the only means by which the object it points to can be accessed. Only C99 adds a new type qualifier called restrict. Now with this, let us move on to the next topic, which is about operators in C++. So we have different operators supporting in C++. They are arithmetic operators, increment or decrement operators, assignment operators, relational operators, logical operators, and finally the bitwise operators. Firstly, let us understand about the arithmetic operators in C++. Arithmetic operations are used to perform mathematical calculations such as addition, subtraction, multiplication, division, and modulus. Followed by that, we have the increment or decrement operators. The increment or decrement operators are used to increase the value of a variable by specific number, and similarly, decrement operator is used to decrease the value of a variable by a specific number. Now let's move on to the assignment operators. The assignment operator in C++ is used to assign the values to a particular variable. For example, equals to and double equals to. Int a is equals to 10 is the simple example for assignment operators. Then we shall move on to relational operators. The name itself indicates the operation of this particular operator. The relational operator is a programming language construct or operator that tests or defines the relationship between two entities or variables. So the basic examples for relational operators are greater than, less than, equals to, not equals to, and few more. Then we have logical operators. These operators are used to perform logical operations on given expressions. There are three logical operators supporting in C++ language. They are logical and, logical or, and logical not. Finally, we have the bitwise operators. These operators are used to perform bit operations. Decimal values are converted into binary values, which are a sequence of bits, and bitwise operators work on these bits. So the bitwise operators supporting in C++ language are bitwise and, bitwise or, bitwise not, XOR, left shift and right shift. So with this, we shall conclude with operators and move on to the next part, which deals with the control statements. So what are control statements? Control statements enable us to specify the flow of program control. They specify the order in which the instructions in a program must be executed. They make it possible to make decisions to perform tasks repeatedly or to jump from one section of the code to another. So the following are the control statements in C++ programming language: if statement, if else statement, if else ladder, nested if, switch, and break. First, we shall learn about if control statement. If control statement in C++ is defined as a programming conditional statement that, if proved true, performs an operation and displays the information inside that particular statement block. Let us understand the flowchart of if control statement. Basically, the control begins by executing the beginning parts. So after executing the start part, it enters or encounters the first condition. If the condition happens to be true, then the control enters the condition and executes the statements provided in that particular condition block. If false, the control first executes the start blocks, then it encounters the first condition. This condition is none other than the if condition. If the condition is true, then the control enters the condition and executes the statements which are present inside the condition block. In case if the condition fails, then the control flows outside the condition and executes the statements which are present outside the condition block. So this is how if control statement works. Now, let us try to execute a sample program to understand the functionality of if control statement. So this particular example is based on if conditional statement. So here I have declared a variable a which stores the value 100. So the if condition is if a is less than 200, then this particular statement should be executed. Else only one particular statement which is outside the if block should be executed. Now let's run this program. We can see that the program has been successfully executed, and since the condition is true, this particular statement, which is a message which says a is less than 200, is been printed in the terminal. So this is how the if statement works. Now let's move to the next type of conditional statement, which is if else control statement. So the if else control statement in C++ is defined as a programming conditional statement that has two statement blocks over one condition. If proved true, then the if block will be executed, and if false, then the else block will be executed. Now let's check out the flow diagram to understand its functionality. So firstly, the start block will be executed as usual. Followed by that, we have an if condition. If the condition is true, then the control enters the if condition and executes them. If false, then the condition enters the else statement and executes the else statements. Once after either of the statements are executed, the control flows outside the if or else block and executes the statements which are present outside those blocks. This is how the if else conditional statement works. Now we shall execute a sample program to understand it in a much better way. So this particular example is based on else if conditional statement. Now let's execute it. You can see that I have given a is equals to 100 and b is equals to 200. In case if b is greater than a, then if block should be executed. Else, an else block present after the if block should be executed. Since b is less than 200, the first if block is executed here. Now let's move on to the next type of control statement, that is the if-else ladder control statement. The if-else ladder in C++ language is defined as a programming conditional statement that has multiple if-else blocks. If any of the condition is true, then that control will exit the if-else ladder and execute the next set of statement. Now let's see the flowchart to understand if-else ladder in a much better way. So here the control begins at the start statements. After that, it has a set of conditions provided in here. Starting from the condition 1, condition 2, condition 3 followed by that, we have the last condition which is the condition n. So what exactly happens here is the control checks for a valid condition. If condition 1 is true, then the statements in the condition block are executed and it leaves the block. If in case the condition 1 fails, then the control will flow to the upcoming condition and the condition is checked. If in case true, the statements are executed and the control leaves the block. In case if all the controls fail, then it reaches the last condition and checks for the valid statement. If the statement is valid, then that particular statement will be executed. Else, the control will skip all the if statements and finally execute the last statements which are followed after the if-else ladder block. So that's how the if-else ladder works. Now let's see a practical example to understand its functionality in a much better way. So this particular example is based on else-if ladder. So here I will be entering the score of a student. So in case my score lies between 90 and 50, then my grade will be A. In case my score lies between 50 and 35, then my grade will be B. In case it is less than 35, it's supposed to be C. And if it is invalid score entered by the user, then it is set as failed. Now let's try to execute this program and see how does it work. You can see the program is getting compiled and now I'm supposed to enter my score. Let us enter 90. You can see my grade is A, which is printed here. Now with this, let's move on to the next type of control statement, which is the nested if control statement. So the nested if control statement in C++ is defined as a programming conditional statement that comprises another if statement inside the previous if statement. Now let's see the flowchart to understand its functionality in a better way. So here, the control begins at start block and executes the first outer if statement. If the condition is true, then the control enters inside the if block where it encounters another if statement. In case if the control sees the condition fails, then it will exit as it is. Now we shall assume the condition is true. Once after the control enters the second if block, it checks for the second condition. If it is true, then statements will be executed. Else, the else statements will be executed. So this is how a nested if statement works. Now let's try to execute a simple program to understand nested if statement. So this particular code is based on nested if statement. Let's try to execute it. Before that, you can see that the outer if has a is equals to 100. In case if a is equals to truly 100, then it enters the if block and the next if condition is checked. In case if it is false, then the control will directly exit the outer if block and execute the two out statements which are present outside the if block. Now let's try to execute this. You can see that the outer if block failed, so the statements present outside the conditional block have been executed here. Now with this, let's move on to the next type of control statement, which happens to be the switch control statement. Switch case in C++ is defined as a programming selection statement that checks for a possible match to the provided condition against the available cases. If none of the cases match, then the control will execute the default statement block. This is similar to else if ladder. Now let's check out the flowchart to understand this in a much better way. So here, the control will first enter the switch expression and checks the condition. If the condition matches with case 1, then the statements inside the case 1 will be executed and the control leaves the switch block. Similarly, if the case 1 fails, then it checks for the validity in case 2. If case 2 finds a match, statements 2 will be executed and exits the switch statement. In case if case 2 also fails, then case 3 is checked and statements 3 will be executed. And finally, it will exit the switch statement. In case if all the cases fail, then there is a default statement in switch expression which will be executed, and after that the control leaves the switch case. So this is how the switch case is been designed to work with. Now let's execute a sample program to understand this in a much better way. So this particular program is based on switch control statement. We have 3 cases inside here and I have provided one particular choice, which is 3. If case 3 is matched, then the message inside the case 3 should be printed. Now let's execute this program and see the output. You can see that case 3 found a match and the message inside the case 3 block has been executed here. Now with this, let's move on to the next part of our tutorial, which happens to be the break statement. The break statement in C++ programming language is defined as a programming conditional statement that is designed to exit the control from the current code segment to the next code segment when a specific condition is satisfied. Now, let's check the flowchart. Firstly, the condition is checked. The control checks the condition, and if it finds the condition is valid, then very next, the control flow from that particular block of code will be blocked and the control takes an exit. In case if the control finds the condition to be invalid, then the same condition is continued for one more time. So this is how the break control statement works. Followed by this, let us continue with the loops in C++ program. So what are loops? Loop control statements in C++ are used to perform looping operations until the given condition is true. Control statements come out of the loop statements once the provided condition becomes false. So there are three different types of loops in C++ programming language. They are do while loop, and for loop. Let us understand each one of them in a much better way. Firstly, we shall deal with the for loop. The for loop can be defined as a precise loop which has initialization, condition, and increment or decrement operator. So the for loop has three different parts. Firstly, initialization comes in the first position. Later, we have the condition provided by the user. Then we have a valid increment or decrement operator. Now let us check out the flowchart to understand the functionality of for loop. The control begins at the initialization state, and once after the initialization is done, then the control checks the condition. In case if the condition is true, then the statements inside the for loop will be executed, and once the statements are executed, the control flows into increment or decrement operator and performs the operation of increment or decrement as per the user's request. Once after the process is done, then the control will again enter the condition and checks the condition's validity. If the condition is valid, then it enters the loop again. In case if the condition is false, then it will exit the for loop. This is how the for loop works. Now let's try to execute a program to understand the working condition of for loop. So this particular example is based on for loop. So here I've provided the initialization variable as I is equals to 1. Followed by that we have the condition which says that I should be less than or equal to 10. And lastly, I've provided the increment operator. Now let's try to run this program. You can see that the program has been successfully compiled and the numbers starting from 1 to 10 are being printed here on the terminal. So this is how the for loop works. Followed by this, let's deal with the nested for loop. The nested for loop is completely similar to that of the for loop, but the only difference is the external for loop includes an inner for loop. Let's check the functionality. The control begins at the start statements. Firstly, the outer for loop is executed. In case the condition fails, the control exits. In case the condition is true, then it encounters the inner for loop. If the control finds the condition in the internal for loop is true, then it executes the internal for loop. Else it exits. So this is how the nested for loop works. Now let's move on to the while loop. While loop can be defined as a loop which executes itself repeatedly until a given Boolean expression or a condition is true. Now let's check out the flow diagram. The control begins at a decision. In case if the decision is true, the statements inside the while loop will be executed, else the loop will be terminated. Now let's try to execute a simple program to understand the functionality of while loop. So this particular program is based on while loop. Let's try to execute it. The program should be working for generating factorial numbers of the given number. Now I have inputted 10. Let's generate the factorial numbers here. We have the factorial number of 10 as 3628800. Now let's move on to the next type of loop, which happens to be do while loop. The while loop and do while loop are completely similar to each other, but the only difference is the condition block will be placed at the end of the while loop. So here the control begins at the execution of statements first. Once after the statement is executed, then the condition is checked. If the condition is true, then the statements will be executed again. In case if it is false, then the control exits the do while loop. Now let's execute a sample program to understand do while loop in a better way. So this particular example is based on do while loop. Now let's try to execute this. We can see that the program is getting compiled and the output has been generated here. The value of num from 1 to 6 are being generated here as per the condition provided here. Now with this we conclude the basics of C++ tutorial. Now let us move on to the next segment of our today's tutorial, the object-oriented programming. Object-oriented programming system is a programming paradigm based on the concept of objects that contain data members and methods related to them. The primary purpose of object-oriented programming is to increase the flexibility and maintainability of programs. Now, let us discuss the important features of object-oriented programming. The object-oriented programming emphasizes more on data rather than procedure. The programs are divided into objects, thus making it easy to work within. Data structures are designed in such a way that they characterize the objects. Functions that work on the data of an object are placed together in the data structure. Data is hidden and cannot be accessed by external functions without permission. This is because of the access modifiers. Communication between objects can take place with the help of functions. Adding new data and functions has become very easy. The object-oriented programming paradigm follows the bottom-up approach in the program design. Now let us discuss the important steps included in object-oriented programming. Firstly, we have encapsulation. Encapsulation can be defined as a process of wrapping up the data and information under a single unit. In object-oriented programming, encapsulation is defined as binding together the data and their related functions. In other words, wrapping the data together with the functions that manipulate them. We can implement encapsulation using the three access modifiers, which are public, private, and protected. Now, we have some types of encapsulation. The types of encapsulation that C++ supports are member variable encapsulation, function encapsulation, and class encapsulation. Let us go through a simple example to understand how encapsulation works in C++. So this particular example is based on encapsulation. Now let us try to execute it. Now we can see that the program is been compiling and the encapsulation is been applied onto all the classes present in the program. Now let us move on to the next topic, that is the abstraction. Data abstraction is a programming technique for separating the interface and implementation details. This provides only the important details and hides the complicated code segments of the program. There are three main access specifiers implementing abstraction, which are public, private, and protected. There are basically three ways to apply abstraction in C++ programming language. That is, abstraction using classes, abstraction using header files, and finally, abstraction using specifiers. Now, let us go through a simple example to understand the terminology of abstraction. So this particular example is based on the terminology of abstraction. Now, let us execute this program and see how does it work. As you can see, the program has been successfully compiled and the abstraction process is being applied upon the classes that are meant to. Now, let us move on to our next topic, that is inheritance. Inheritance is defined as a process of acquiring all the properties and behaviors into the child object from its parent object automatically. There are 5 types of inheritances available in C++ language. They are single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and finally the hybrid inheritance. C++ uses access specifiers to limit the access of base class attributes to the derived class. There are totally 3 types of access specifiers in C++. They are public, private, and protected. Let us see through some examples to understand inheritance in a much better way. So this is a basic example of inheritance. The class trainInfo happens to be the parent class and the class bulletTrain happens to be the child class. Here, we are inheriting the properties of class train into the class bulletTrain. Now, let us execute this program and see the output. As you can see, we have successfully inherited the properties of train class into the bulletTrain class. Now, let us move a bit further and execute a program based on single inheritance. This particular example is based on single inheritance. Single inheritance is a type of inheritance where the child class inherits the properties of one parent class. Now here, a program has been successfully executed and now it is asking for a name as an input. As you can see, the data has been successfully displayed here. And now let us execute an example based on multiple inheritance. Multiple inheritance is a type of inheritance where one child class inherits the properties of two or more different parent classes. This particular example is one of a kind. Let us execute this and see how does it work. As you can see, we have inherited the properties of multiple classes into one child class, and the output has been displayed here successfully. Now, let us move on and execute another example based on multi-level inheritance. Multi-level inheritance is a type of inheritance where the class inherits the properties from two different levels of parent classes. For example, here, class base is the topmost class or the first class. Derive 1 is the second class, which is inheriting the properties of the parent class base. Here, we have another child class on the name derive 2. So, what happens here is derive 2 inherits the properties of derive 1, which is in turn inheriting the properties of the first parent class, which is base. So, this is how multi-level inheritance works. Now, let us execute this program and see the output. You can see the program has been successfully compiled and now it is asking me for an input. Similarly for Y, then for Z, and here's the output. So this is how multi-level inheritance works. Let us move on to the next type of inheritance, which is none other than the hierarchical inheritance. Hierarchical inheritance is completely similar to multi-level inheritance. Now let us execute this program and see how does it work. As you can see, the program has been successfully compiled and the output has been generated here based on hierarchical inheritance. Now finally, hybrid inheritance. Hybrid inheritance is a combination of two or more previous types of inheritance. That is, hybrid inheritance can include multi-level inheritance and multiple inheritance, or multi-level inheritance and single-level inheritance, or the combination of any other inheritances types. So this is a program based on such a kind. Now let us execute this and see the output. As you can see, the program has been successfully compiled and the output has been generated. Now with this, let us move on to the next concept in our tutorial for today, that is overloading. So what is overloading? Overloading is a process where we create two or more members of a class having same name but different number of parameters. We can overload by using methods, constructors, and indexed properties. There are basically two types of overloading, which are functional overloading and operator overloading. Now, let us execute an example based on overloading. So this particular example is based on function overloading, and here we are having two methods on the same name, that are add and add. One method is having two parameters and the other one is having three parameters. Now let us execute this program and see how does it work. As you can see, both the functions have been executed successfully without any problem, and we have the results of the functions as well. Now let us move on to the next topic, which is overriding. When a derived class has a function with the same name as a function of the base class, then it is called as function overriding. Both functions must have the same number of parameters in both the classes. Now let us execute a program based on function overriding to understand the terminology in a better way. So this particular program is based on functional overriding. Here we have a function called disp in the base class. Similarly, we have another function in derived class with the same name called disp. So let us execute this program and see how does it work. You can see that the program has been successfully compiled and the output has been displayed here. So this is how the overriding works in C++. Now let us take a step further and find out the differences between function overloading and function overriding. First difference is that the scope is same in overloading, whereas in overriding the scope is completely different. Then the second difference. Signatures must differ when you're overloading, but whereas signatures must remain same when you're overriding. The next difference is multiple overloading is possible, whereas multiple overriding is not possible. And the last difference between the both is overloading can occur without inheritance, while overriding will occur only because of inheritance. Now let us move on further and understand interface. The interface is a solution to implement the behavior and functionalities of the parent class into the child class from its parent class without the actual involvement of the members of the parent class. So this is the syntax for applying interface in C++, which is double underscore with interface, which is the keyword. Followed by that, we have to mention the interface name. And inside the block, you can have your own statements. Now, let us execute a program based on interface to understand its terminology. So this particular example is based on interface. Now let us execute this and see how does it work. As you can see, the program has been successfully compiled and the output has been generated here. Now let us move on to the next concept, which is friend. A friend function of a class is outlined outside that particular class's scope. However, it is possible to access all the private and protected members of a class. Basically, this property is a bit insecure when it comes in the real time. However, let us see the syntax to use friend functions in C++ programming. Class is the keyword here. Followed by that, you have to provide the class name to which you have described your friend function, and inside the block you have to use the keyword friend. Followed by that, you have to place a data type and the function name inside which you have the arguments. Now let us execute a program based on friend function to understand its terminology in a much better way. So this particular example is based on friend function. Now let us try to execute it. You can see that the program has been successfully compiled and the result is displayed here. Followed by this, let us move on to our next concept, that is constructor. The constructor is considered as a member function of a particular class. It is mainly used to initialize the objects of the class. It is provided with the same name that we have provided for the class. Now there are three types of constructors. They are default constructor, parameterized constructor, and finally the copy constructor. Let us execute a simple program based on constructors to understand their terminology. So this particular program is based on constructors. As you can see, the program has been successfully compiled and we have the results here. Now let us move on to our next topic, which is the destructors. So what is a destructor? Destructor is completely similar to the garbage cleaner in Java. How does destructors in C++ work? Destructors are another type of member functions that are responsible for destroying or deleting the object. It frees up the space occupied by the object after it is no longer needed. It is completely similar to the free method which we use in dynamic memory allocations in C programming. Now the syntax for destructor is destructor name, but care should be taken that the tilde symbol is used in front of destructor name. Now let us execute a simple example based on destructors. So this particular example is based on destructors. Now let us try to execute it. You can see that the destructor has been successfully executed and our output has been generated. Now let us move on to the next topic here. The next topic is the STL, Standard Template Library. The Standard Template Library is a set of C++ template classes to provide common programming data structures and functions such as list, stack, arrays, etc. STL has three components. They are containers, algorithms, and iterators. Now with this, we have concluded with the object-oriented style of programming. Now let us move on to the advanced programming concepts in C++. First one, file handling. Files and streams. Files are used to store data in a storage device permanently. In C++, we have a set of file handling methods. These include ifstream, offstream, and fstream. What is offstream? This stream class signifies the output file stream and is applied to create files for writing information into files. Then we have ifstream. This stream class signifies the input file stream and is applied for reading information from files. Finally, we have fstream. This stream class can be used for both read and write from and to files. Now, let us execute basic examples for understanding file handling methods in C++. Now, let us try to create a file. So this particular code segment is used to create a file. Let us name our file as Edureka. Now let's run the code. As you can see, a new file has been successfully created and our file is right here. Now let us try to execute another program which follows the write function into the file. Now this particular code is used to write data into the file that we have created. So the data that we will be writing into our file is Edureka Happy Learning. Now let us try to execute this code. As you can see, the message has been successfully written into the file and the message has been displayed here. Now let us try to execute another program which reads the data present in our file. So this particular code is used to read the data which is present in our file. As you can see, the compiler is reading the message that we have written into our new file, that is edureka.txt. Now we shall execute the last program based on file handling techniques, which is used to close the file that we have opened. So this particular code segment is used to close the file that we have opened, which is edureka.txt. Let us run this code to close the file. As you can see, the code has been successfully executed and the file has been closed. Now with this, let us move on to the next segment, which deals with exception handling. So what is exception handling? Exception handling is a phase which deals with the handling of errors and exceptions that rise in runtime due to the mistakes in code or invalid inputs entered by the user. In C++ programming language, we have two types of exception handling, that are runtime exception handling and compile time exception handling. Let us go through some examples to understand exception handling in a better way. So this particular example is based on exception handling, and we are going to try the try and catch block here. You can see that the code has been successfully compiled and the code was designed to divide 25 by 0, and the exception should be attempted to divide by 0, which is displayed here in the terminal. Now let us try to execute another example based on exception handling where the catch block will be facing a failure. Let us see how does it happen. You can see that the code has been successfully executed. This kind of approach is used when catch block and try block both face failures. So in this situation, we have to specify a default catch block which will execute a default exception. As you can see, we have default exception message printed here in the terminal. Now let us try to execute one last example based on exception handling, which is having multiple catch blocks in a program. So here we have multiple catch blocks included in our program. Now let us try to execute this. You can see that the code has been successfully executed and the output has been printed here. Now with this, let us move on to the next segment where we will learn dynamic memory management in C++. Firstly, we shall deal with dynamic memory allocation. Dynamic memory allocation can be defined as a procedure in which the size of a data structure is changed during the runtime. In C++, the new operator is used to allocate memory at runtime, and the memory is allocated in bytes. So the syntax for dynamic memory allocation using the new keyword in C++ is data type pointer is equals to new keyword and the data type. Now let us execute an example based on dynamic memory allocation. As you can see, the code has been successfully executed and you can see the memory allocated for the data in our program, which is 1, 2, 3, 4 and 5. Now with this, let us move on to the next concept, that is deallocation. Deallocation acts as the free method in C programming. Once heap memory is allocated to a variable or class object using new keyword, we can deallocate that memory space using delete keyword when the memory is no longer needed. This improves the program efficiency. Let us move on to the next concept, that is signal handling. Signals are the interrupts delivered to a method by software package which may terminate a program untimely. You'll be able to generate interrupts by pressing Ctrl+C on an operating system, Linux or Windows OS. Now we shall execute a simple example based on signal handling where we'll try to print a message called Welcome to Edureka. Now let us run this program. As you can see, the program has been successfully executed and the terminal is starting to produce the signal Welcome to Edureka for infinite number of times. Now we have to stop this in order to cancel the signal generation. We have to just press the stop button in order to stop the signal generation. The signal generation has been successfully stopped. Let us move on to the next concept, which is multi-threading. Multithreading is a special sort of multitasking, and a multitasking is that feature that enables your PC to run two or additional programs at the same time. In general, there are two kinds of multitasking. First one, process-based, and the second one is thread-based. Process-based multitasking handles the execution of programs. Thread-based multitasking deals with the execution of items of identical programs. A multi-threaded program contains two or additional elements which will run at the same time. Every part of such a program is termed as a thread, and every thread defines a separate path of execution. C++ does not contain any constitutional support for multi-threaded applications. Instead, it depends entirely upon the OS to produce this feature. The C++ programming language has the following stages in multi-threading. First, to create the thread. Next, pass arguments to the thread. Then, join or detach threads. And finally, to terminate the thread. Now, let's execute all these four stages to understand the terminology of multi-threading. And before that, let us understand the syntax of multi-threading. So in the syntax of multi-threading, we are supposed to include the library which is pthread.h in the program in which we are processing multi-threading. Let us execute the program for creating a thread. So this particular program should successfully create a thread. You can see that there are threads created and the message is being printed along with the threads. Now, followed by this, we shall try to pass some arguments to different threads. So this particular program should be able to pass multiple messages to multiple threads. Let us execute that. You can see that the output is being generated here, and we have created 5 different threads and we have allocated a single message to every single thread. Now with this, let us move on to the next stage where we will try to join and detach threads. So this particular program should join and detach threads. Let us execute this. You can see that we have created 5 different threads and we have attached 1, 2, 3 and 4 threads, and the 0 thread is being detached. Now with this, let us continue with our final process, which is none other than terminating a thread. So the syntax for terminating a thread is include pthread.h library, and you need to write pthread exit status. And that's how you terminate a thread. Let us continue with our next topic, that is containers. Associative containers that store elements in a mapped fashion are called as maps. All the elements in a map are stored in a key-value pair, but each key is unique. Sorting is done with the help of keys and the values are associated with each key. Values can be inserted and deleted whenever required. So the syntax for a container is map key type, value type, and map name, followed by a semicolon. Now we shall execute an example based on containers. So this example is based on containers. Now let us try to execute it. As you can see, the program has been successfully executed and we have the container where we have the roll numbers along with their marks. Let us try to execute another example based on containers. So this is another example based on containers. Now let us try to execute this program and see the output. You can see that the program has been successfully compiled and the output has been successfully generated here. The output is the key value pair which has been displayed here. Now with this, let us wind up our session with some most important interview questions that are asked based in C++. So we shall deal with 4 important programs. They are Fibonacci numbers in C++, then followed by that we have quicksort in C++. Then we shall understand call by reference in C++, and finally what is type conversion in C++. These interview questions are answered in detail in the article written based on C++ tutorial. The first one is the Fibonacci series in C++. Now let us try to execute the first program, that is generating Fibonacci series using C++. So now let us enter the numbers. You can see that I have entered the number as 5 and the Fibonacci series for the same has been successfully generated here. Now let us try to execute the second program, which is none other than the quicksort in C++. Don't worry about the code, we will mail you the code whenever you ask it for. So this particular code is designed for running quicksort algorithm using C++. Now let us try to execute this. As you can see, the code has been successfully executed and now it is asking for the number of elements to be sorted. Let me give a random number, that is 10. Now let me provide the elements to be sorted one by one. Firstly, I'll provide 5, then I'll provide 1, next 4. Followed by that, let me enter 6, then 7, then 8, later 2, then 3, then 9, and finally 10. Let us see if the numbers get arranged in a proper way or not. You can see the numbers have been successfully arranged in the proper manner, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now with this, let us move on to our next question, that is call by reference. Let us execute a simple example based on call by reference. So this particular example is based on call by reference. This example has been already executed while we were discussing call by reference in reference variables, though we shall try to execute this one more time. You can see this program has been successfully compiled now and we got the output, and the output has been displayed on the terminal. Finally, we reached to the last question, which is type conversion in C++. So what is type conversion in C++? Type conversion refers to the conversion from one type to another. The main idea behind the type conversion is to make variable of one type compatible with the variable of another type to perform an operation. Now let us try to execute a simple example to understand type conversion. So this particular example is based on type conversion. Now let us try to execute this program and see how does it work. As you can see, the code has been successfully executed and the output has been generated. As we specified in the code, we have 3 different variables of 3 different data types. Firstly, we have int1, which is an integer data type which is saving 100 as its value. Followed by that, we have a character1 variable which is of character type which saves C inside it as its value. And third variable is FLT1, which is a float data type variable which will be storing the sum of integer 1 plus 2.7. As we specified the operations, firstly, integer 1 will be saving the value of integer 1 plus character 1. We have integer 1 that is 100 and character 1 C. So the value of character C in ASCII is 99. So the summation of 100 and 99 gives us 199. And now finally we have FLT1, which will be storing the value of int1 plus 2.7, that is 199 plus 2.7. Now what happens is that the data type int will be converted into float and the final value, which is none other than 201.7, will be stored in FLT1 variable. So this is how type conversion takes place. So with this, we have come to an end of this session. If you have any queries related to this session, or if you require the codes for any of the examples that we have executed during this session, then please write to us in the comment section below and we will respond to you as soon as possible. Till then, thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!